Okay, good morning. Today I want to share with you one of the uh, principles behind Kirchoff's Law. You see, Kirchoff's Law has been one of the basic network theorems. And most of the times when you get a large circuit and you want to easily solve it or analyze it, sometimes using Kirchoff's Law or Kirchoff's theorem will help. So there are some few rules governing this Kirchhoff's law, and I'm going to share it with you. So no matter how the circuit is, you just follow these few rules and you'll be done. So actually, after this, we are going to demonstrate all these theorems on the practical aspect. So let's first of all look at some few examples. So let me take just a simple circuit that you ever have in an electrical circuit. So let's say we have a circuit with two sources. So let me put another resistor here. Then we have our two sources this way. Now, let's say I have 3 volts here. I have 6 volts here. We have 2 ohms, 3 ohms, then maybe 4 ohms. This is very simple. You may have more complex circuits, but when you get the basis right, later you can apply whatever that I'm teaching you here to those complex circuits. So let's state the rules. Rule number 1 says that when you have a circuit like this, first of all, assign potential arrows. Assign potential arrows to the sources that you have. So whenever you want to assign a potential arrow to a source, whether it is a battery or any AC system, you always let the arrow point to where the positive terminal is. So when I take this system, I have the positive terminal to be here, so I will assign my potential arrow this way. Then this one too, I assign the potential arrow in that order. Now our next step is to choose our own current direction. So this circuit, I will choose whether these two should all be discharging to the circuits, or this battery will be charging this while this one will be discharging. Or let's say this one will rather be discharging to charge this, or we let this one rather discharge to charge this. So you can choose any of them. Either current will be moving this direction to supply this resistor, this one, and also this. Or we let this one discharge to supply this resistor, this, and this battery. Or on the other hand, we can let both discharge onto the circuit. Either direction that you pick, you'll still get your answer. Now, there is something going on in Kirchhoff's law. After choosing this direction that I'm going to deal with, if finally I get any of the current values to be negative, it tells me that the direction that I chose was wrong. But then the value will always be the same. The direction will just change, then you just change it for good. Now, let's see. So I will prefer the two batteries discharge onto the system. So let's say current coming from here is called maybe A or IA. So let me see IA. Let me see I naught. I naught is the best. Then the current, when we get here, we are going to apply Kirchhoff's first law here. So if I want another current to move from here, as I stated earlier, then I'll have this place to be I1. When I0 and I1 come together, they all flow through here. Now, there's another choice to make here. You can choose to make this place I1 plus I2, or we can call it I3. We will all come out with the same answer. The only difference is that the one who chose I1 plus I2 to flow this way will end up having two variables in his or her simultaneous equation. And when you are dealing with two different variables in a simultaneous equation, it tells you that you are going to deal with two equations with two unknown variables. On the other hand, if I choose this place to be I3, still I'm not wrong. The only difference is that I'm going to end up with three unknown variables, which is I0, I1, and I3, or maybe I0, I1, and I2. So that's the difference. Now let's continue. So I would rather like to call this place I0 plus I1. Now the next thing is that, so let me write this point. You choose the current direction. Now our third point is that we assign potential arrows to the components. You see, we are done with the sources, but then for the components, we've not given them potential arrows. So we assign potential arrows to the components. You see, they do not produce any source of energy, so we assign them at this time. Now, since current is moving this direction, the potential arrow for this resistor should go opposite to the current. At this point, current is moving this direction, so my potential arrow should go this way. Then at this point, the current is coming down, so my potential arrow should go up. This is a rule that you should follow strictly, or else you end up getting your answer to be wrong. Now, the fourth point is that we write the loop equations. But somebody will ask, how many loops are we having in this circuit? So let me label the circuit. You have A, B, C, D, E, and F. So these are the junctions that we have, or the nodes. Now, how many loops are we having? We are having 3 loops. The first loop is loop F, A, B, E, F, or A, B, E, F, A. The next loop is B, C, D, E, and B. That's the second loop. The third loop is A, C, D, E, F, and A. So we are going to base on this to write our loop equations. So in the next video, I'm going to help you to deal with the loop equations. Thank you.